So we do the Taylor series. Right? For each of those functions, we pass to the linear terms. What does it mean to pass to the linear terms? Because for the numerator, we can hope to do it algebraically, because we have a formula. For the denominator, we don't have a formula. But can we still make sense of the first term of the Taylor series, of that function, whatever the function is? How can we do it? Because algebraically, I know I would take a derivative. Right? Can I take derivative? Well, I cannot because I don't have a formula. Can I do something about this denominator geometrically? Because remember, we had geometric meaning of the first degree term. First degree term is about linear behavior. Right? So what I'm looking for at this point is linearization of that denominator. Either geometric or physics. What would be linearization of that from physics point of view? Isn't it about the constant speed motion? Right? That's what the first term is from physics point of view. So we replace the strange motion, arbitrary motion, with the constant speed motion. And that's how we linearize. So to linearize, I think of limit as delta t goes to 0. And now the distance traveled under the constant speed motion. What's the speed, by the way? It's the speed at that point t0, right? So the speed is the magnitude of f prime of t0. F prime of t0 is velocity, its magnitude is the speed. A constant speed motion produces the distance traveled being the speed times delta t. So we are gaining some benefits of having different points of view. We don't need the exact formula for the distance traveled. And by the way, if you still remember something from calculus 2, the distance traveled is an integral, right? So we would have to recover an integral here, the exact formula for the distance traveled, and then we would have to differentiate that integral, which is kind of a long process in comparison to. All right, so we linearized, and of course the exact formula is that plus something, but for now we are going to ignore the rest because that is considered the main term so far. And now I have to linearize the numerator. So what do I see in the numerator? Well, some function that I don't know, but I can differentiate, right? Derivative of f prime is f double prime. Some constant t0 and a variable delta t floating around. And I have to differentiate with respect to which variable? Is it with respect to t0? Let's go back to the Taylor series. When I differentiate here, do I differentiate with respect to x or with respect to a?
With respect to x.
I differentiate with respect to x, but then I plug in a, right? So that means here I have to differentiate the whole thing with respect to delta t, and then plug in delta t equals 0. So we have to treat the whole formula in numerator as a function of delta t. It shows up there. Right? Differentiate the whole thing with respect to delta t, and then substitute delta t.